So to repeat, this is quiz 1, number 1. We have a simple curve, central angle 36, degree of curve 6. So central angle, that's this angle, 36, degree of curve 6. Also, that central angle is your point of intersection, or angle of intersection 36 as well. For letter A, we're looking for distance, midpoint of curve to point of intersection of tangents. So that's this point. Midpoint of curve to intersection of tangents, that's just your E, if you're familiar with your parts of a curve. So we're looking for E. So the equation for E is r secant I over 2 minus 1. So I is already given. That's 36. Now my problem is how to get r. And remember, when you have a degree of curve, you can immediately solve for r using this 20 equals rd. Okay, so by the way, please use the equations that I've given, not what you see online. 20 equals rd. What kind of basis is that? If you remember. So mostly we're using, let's check our notes. Arc basis. Okay. So you'll mostly use 20 equals rd unless otherwise stated. For example, the problem says use chord basis, then this is the equation that you'll use. Okay. So for now, it's just 20 equals rd. Okay. 20 equals rd, so 20 equals r times 6 degrees. But remember, whenever you're using an angle outside of its trigo function, you always have to convert it to radians. That's why the 6 degrees convert to radians, that's pi over 180. Solving for r, you get 190.99. Plug that into your equation. So 190.99 times secant 36 over 2, that's your I, 36 and minus 1. Final answer, 9.83 meters. Next, number 2. Letter B, compute the distance from the midpoint of the curve to the midpoint of the long chord joining the point of curvature and point of tangency. So point of curvature is this point. Point of tangency is this point, so this is your long chord. Okay? So the midpoint of that to the midpoint of your curve is this length. That's what we're looking for. And again, if you're familiar with parts of your curve, that's just your n. Okay? So now we're looking for n. So recalling the equation for m is r1 minus cosine I over 2. So that's pretty easy. I already know r. I already know I. So just plug in your values. 190.99 times 1 minus cosine. I, again, is 36 over 2. Solving for that, you get 9.35. Okay, next. Letter C. If the stationing of the point of curvature is 10 plus 0 to 0, compute the stationing of a point on the curve which intersects the line, making a deflection angle of 8 degrees with the tangent through PC. So the tangent through PC is this line. Tangent through PC. And then we have another line making a deflection angle with that tangent. So draw a line making a deflection angle 8 degrees from your tangent. Okay? So from PC to that line, that's it. It intersects your curve at point A. So what are we looking for? Stationing of that point. So we're looking for station A. Okay? And remember, stationing is along the curve. So that means, to get the stationing of this, I need to know the length of this curve here, this arc length. Okay? So we're given station PC, right? Yes. So to solve for station A, as you can see, station A now is just station PC plus arc length, so plus S. And remember the equation S equals R theta. So that is what we'll solve. S equals R theta, considering this segment. So R is this, your radius, and they're equal. Okay, so R is still 190.99. This is 190.99, hence R. Now what's theta? Well, remember for a simple curve, your deflection angle is equal to half your central angle. It's what you've been doing during your field works, right? So for example, this is your chord. Deflection angle from tangent is 8. Therefore, central angle, or the angle subtending your chord, is twice that. So this is 16. Okay? So 8 twice that, this is 16. Same thing here. If you have another angle, you have this theta. Okay. This angle would be twice theta. Right? So now I know this is 16. So theta is 16. And again, reiterating, when an angle is outside the trigo function, you need to convert it to radians. So this is 16 degrees, convert to radians, pi over 180. Therefore, S is 53.33. So solving for that, that's just station 10 plus 020 plus 53.33. You get 10 plus 073.33. Okay, so that's number one. Next, let's move on to number two. A simple curve has tangents AB and BC intersecting at a common point B. AB has a south azimuth of 180 and BC has a south azimuth of 230. The stationing of the point of curvature at A is 10 plus 140.26. If the degree of curve of a simple curve is 4, let's start with letter A. Compute the length of the long chord from A. So again, first step, try to draw what's happening. So let's start sentence by sentence. Simple curve tangent ABBC intersecting at B. Then AB has a south azimuth of 180. That means south azimuth of 180, you're going to start at the south line and rotate clockwise by the amount of degrees. So rotating clockwise, this is 180. So therefore, that is your line AB. Hence here, south line, rotate 180 clockwise. So this line happens to be a vertical line, AB. Okay? And then another line, BC, has an azimuth of, and south azimuth 230. So since AB and BC connect at B, so we're going to start, let's say this is your point of intersection. Okay? So you have this point of intersection, south line. So from B, measure 230 degrees. So 230, that's somewhere here. Then draw a straight line from that. That is your BC. Okay, so that's how you draw the tangent lines. Next, stationing of PC is 10 plus 140. And so stationing of this is your PC, 10 plus 140.26. And then degree of curve is 4 degrees. So what are we looking for? Length of long chord. So long chord, that's your capital L or capital C or capital LC. That's just the length between PC and PP, considering this is PP, okay? So it's this length right here. Remember, we have an equation for a long chord. Our equation is 2r sine I over 2. So I need to solve for r and I. I is easy to solve. If you remember, I is just this angle right here. So looking at my drawing, and this is I know this is 180. I know this is 230. So if I get the difference of 230 and 180, I get this angle. That's why here I is just 230 minus 180, so therefore 50. Okay, so now I know I. Next, I want to know R. But again, whenever you have a degree of curve, it's easy to figure out what R is. It's just using 20 equals RD. So 20 equals R times 4 degrees. Again, convert to radians times pi over 180. Therefore, solving for R is 286.48. Sub that into your equation, you get the final answer, 242.14 meters. Okay? Next, letter B, tangent distance AB of the curve. So tangent distance AB, this is a simple curve. Therefore, T1 equals T2, right? That's the definition of your simple curve. And there's also an equation for that. That's just R tangent I over 2. So I know R, I know I can directly solve for this, just plugging in my values R, then I, R tangent 50 over 2, that's 133.59. Okay? So letter B is easy enough. Let's move on to letter C. So here, this gets a bit tricky. Compute the stationing of a point X on the curve on which a line passing through the center of the curve makes an angle 58 with line AB. Intersects the curve at point X. So let's look at it one by one. We want to know stationing at point X. Wherein a line passing through the center of the curve makes an angle 58 degrees with line AB. Okay? then it intersects the curve at 58. So how do we draw that? So first of all, this line hits the center of your curve. Okay? And it makes an angle of 58 with line AB. So draw a straight line. So center of the curve, that's this point. Okay? It's not necessarily this point. Center of your curve is just referring to this. So draw a straight line. So intersecting line AB, this is your line AB. So if I draw that, it's this line right here. I can draw it from this end, right? Because it's not gonna pass through the center, or like it could be this way. Maybe, but it's easier to draw it this way. So this is now your line. It makes an angle of 58. So this is your 58. Hits your long chord. Intersects the curve at point X. This should be your X. So looking for the station of X. So to get the station of X, same thing as number 1. I just need to know this arc length. Okay? To get that arc length, X equals r theta, I need to know this theta. How? So to get theta, look at the drawing. You got yourself a right triangle, right? So therefore, the total internal angle of that is 180. So to get theta, that's just 180 minus this right angle 90. Since your radius always makes a right angle with your tangent. So 180 minus 90 minus 58, you get 32. So this theta equals 32. Now I have my r theta. So S equals r theta. R is this. Theta is, again, 32. Convert to radians, pi over 180. So you get S equals 160. So finally, station X is just your station PC, 10 plus 140.26 plus S160. So final answer, 10 plus 300.26. Okay? Any questions for 1 and 2? Gets naman? Okay. Let's move on to number 3. The offset distance or perpendicular distance, okay, of the simple curve from PT to the tangent line passing through PC is equal to 120.20. The stationing of PC is at 2 plus 540.26. The simple curve has an angle of intersection of 50. Let's start with letter A. Compute the degree of curve. We're looking for degree of curve now. So opposite. Start. So let's draw what's being illustrated or being described. First, offset distance, that means a perpendicular distance of simple curve from PP to the tangent line passing through PC is equal to 120. So meaning, okay, if you draw a simple curve, right, this is your PP, tangent offset again is perpendicular distance from the line passing through PC. So this is PC. The line passing through PC is this line. Therefore, this is your perpendicular distance, making a right triangle or perpendicular, making a right angular perpendicular to that. And that length is 120. Hence, in the drawing, this is 120.20. Okay? Next, stationing of PC is given. And given simple curve angle of intersection 50. So this is your 50. So we're looking for degree of curve. How do we get the degree of curve? So we can't use 20 equals RD yet because I don't know R. Instead, we need to compute for R first. Okay. So to compute that, let's look at R given. If you look here at this area, I've created a right triangle, right? And I know two angles on this right triangle and I know a side. So when you know two angles and a side, you can figure out the other parts of your right triangle, right? And one of those parts is this length. And this length is the tangent of your simple curve. And when I know the tangent of a simple curve, I can figure out r if I know I. And I already know I, it's 50. Okay? So the goal here now is to figure out what this length is using right triangle. Okay, let's see the solution. So considering the green triangle, isolating that, you got 50. This is a right angle, 120t. So using your trigo function, this is your t, use tangent. So tangent, use sine. Okay. Since this is what I know, 50, I want to look for this, which is the hypotenuse of my right triangle, and I know the opposite side. So find 50 equals opposite, so 120 over 20 over hypotenuse. This is your hypotenuse of your right triangle, t. Okay, so solving for t, I get 156.91. Right now, I know t. Remember, the equation for tangent is r tangent I over 2. So use that. So 156.91 equals r. Tangent, again, I is 50, so 50 over 2. I can solve for r now. So r equals 336.49. And now I can solve for d. Okay. So when I solve for this, 20 equals rd, the answer that I'll get for d is in radians. Okay. So to convert that to degree, radian to degree, that's 180 over pi. Or, if you want, just immediately multiply all of this by pi over 180 in the equation. Okay? So that's one way. Or you can solve for d, you're going to get a radian answer, then multiply it by 180 over pi to convert to degrees. Then you're going to get 3.41 degrees, or 3 degrees, 24 minutes, 19.62 seconds. Okay? There, that's how you solve for degree of curve. Next, external distance. That's just E. And we already know the equation for that. It's r second I over 2 minus 1. I already know r. I have I. So just direct sum. So r 336.49 times second I is 50 over 2 minus 1. You get 34.79. And then lastly, compute the length of chord. So length of chord, again, that just means the straight line from PC to PP. That's your long chord. So this is what we're looking for. How do I get that? So we have an equation for L as well. I think that was, let's check. Long chord. 2r sine I over 2. So we can just use that. 2r sine I over 2. Or, for example, you forgot. You can just look at your drawing. Looking at the drawing, I got another, not a right triangle, but a triangle. So isolating that, this is your L. Okay, considering this whole thing. Okay, we have another right triangle if you consider the green portion. Okay, so you have a right angle here. So considering this total right triangle, this is L, this is 120.20. Okay, and then this angle is 25. Why? Again, as a reminder, if this is 50, the deflection angle of that would be that over 2. And the deflection angle of that is this. So 50 over 2, that's 25. Okay? So now this 25. So I can use this another right triangle sine function. So sine 25 equals opposite 120 over 20, 120.20 over hypotenuse. This is my hypotenuse L. So solving for L, you get 284.42. Or again, you can just use this equation, L equals 2r sine I over 2. You're gonna get the same thing, okay? Since they're looking for the same thing. All right. So that's your quiz number 1. Any questions? None? Okay, so do you understand the solution to quiz number 1? Please answer yes or no. Okay, no questions. Let's move on to quiz number 2. Number 1, a compound curve has a length of chord of the first curve of 470. So by the way, quiz 1, simple curves. Quiz 2, compound and reverse curves. So again, compound curve has a length of first curve 470, and the angle that the long chord makes with the chord from PC to PCC and from PT to PCC are 6 and 9 respectively. Assume the long chord is parallel to the common tangent. Letter A, find the length of the long chord from PC to PT. So let's draw that first. So we're given length of the long chord. Again, length of chord of first curve is 470. So that means L1 is 470. Okay, since this is compound and reverse, we got L1 and L2 now. Next, the angle that the long chord makes with the chord from PC to PCC. So that is PC. This is your PCC. This is your PCC. Point of compound curvature is 6. And then from PT to PCC is 9, respectively. So long chord from tangent, right? The line from PC to PCC, that's not tangent. A long chord to line joining PC and PCC. So let's see that. This is your long chord. This is your long chord. This is PC to PCC. Angle between them is 6. Again, long chord, PT to PCC. The angle there is 9, right? 6 and 9 respectively. So that's your drawing. Next, long chord parallel to common tangent. So common tangent, that's this tangent right here. Tangent being shared between your two curves. So they're parallel. So that's why this is drawn this way. So number 1, find the length of the long chord from PC to PCC. So now I want to know this. So to solve that, we can just use geometry, okay? Simple triangles. So first, we know L1. Considering this. Oh, considering this triangle, I can use sine law. Okay? So I know this angle, I know this angle. So total interior angle should be 180. So 180 minus 6 minus 9, that's 165. Therefore, this angle is 165. Okay? I want to know this L. It's a long chord. So that's the longest side of your triangle. So using sine law, side over angle equals side over angle. So let's do that. The side that I know here is L1. Okay, so this is L1, this is L2. So L1 is given L1 over sine opposite. This is the opposite angle, 9. So 470 over sine 9 equals, this is what I want to look for. So L over sine opposite, which is 165. So sine 165. Solving for L, you get 777.61. Okay, so that's just using geometry. Next, part number 2, trigonometry. Number 2, find the radius of the first curve. I want to know R1. So again, I can solve for R1 just using trigonometry. So how? So look for another right triangle. So let's say that involves R1. Because that's what we're looking for, R1. This is my R1. So I can see that this is another right triangle here, right? If I draw perpendicular bisector for your simple curve 1. Okay, again, this is a simple curve. If this is 470, if I draw a perpendicular bisector, there, there. Therefore, this long chord is divided into 2. That's what a perpendicular bisector does. So therefore, if I consider this right triangle, I isolate it here, okay? So this length is now 470 over 2, right? This length is your R1, right? The hypotenuse. There. And how did I get that angle 6 degrees? And look, so this angle is equal to 6 degrees between these two. Okay? And then remember when there are where two angles that are perpendicular to each other have the same angle between them. So consider this line and this line. That's the line or the lines of your angle 6 degrees, right? So the line perpendicular to here is your perpendicular bisector. The other line perpendicular to here is this line. Okay? So therefore, and angle between them equals angle between them. So therefore that's 6. So this is 6 as well. Okay? And since this is a perpendicular bisector, it divides your angle into two equal parts. Therefore, this is also 6 degrees. Okay? So that's why this is 6 degrees. Okay, so this is your right angle. So that's your 470 over 2. Then this is your leg. Then opposite of that is your hypotenuse. So opposite of that is your hypotenuse. Okay, yeah. Now you have your right triangle. Solve for R. Using, again, trig functions. For this case, it's sine. So sine theta equals opposite 470 over 2 over hypotenuse R. I can solve for R. So R is just 2248.19. Good. Done. Next, letter C. Number 3 rather. Find the radius of the second curve. So finding the radius of the second curve, first, if I want to do this method, I need to know L2. Okay? What is given. So to solve for L2, same technique, you're gonna look for right triangles. So you can just look at this right triangle again. Look at this triangle rather, and use sine. So side over opposite angle. So L2 over sine 6 equals what's given. So I'm given L1. So that's 470 over opposite angle 9. So 470 over sine 9. So I can solve for L2. L2 is just 314.05. Now I know L2. We'll do the same technique we did with letter B to solve for letter C. From there. So again, this height is L2 over 2. Your hypotenuse is your R. Okay. Again, it's this right triangle right here. Then, and this angle is 9. So using sine function, sine theta, sine 9 equals opposite L2 over 2 over hypotenuse R2. And again, L2 is solved for 314.05. Therefore, R2 is 1003.78 meters. Yun. Yun lang. Okay? That's number 1. Let's move on to number 2. In a compound curve, point V is the point of intersection. The line connecting point V and the PCC is an angle bisector. Okay, I've discussed what an angle bisector is, or perpendicular bisector. AB is 270 meters and BV is 90. The stationing of A is 6 plus 421, and that of B is 6 plus 721. Point A is a long tangent passing through PC, while point B is along the tangent passing through PD. The PCC is along line AB. So number 1, compute the radius of the first curve passing through PC. So first, let's draw that. Okay, what does that look like? Again, let's do it sentence by sentence. So compound curve B is your point of intersection. The line connecting B and PCC is an angle bisector. So B and PCC, so let's say draw an angle. This is your V, right? Point of intersection. This is your PCC angle bisector, meaning it separates your angle into two equal parts. Okay? Theta equals theta. Next, AV is 270. So we have a point A to V, that's your 270. Next, BV is 90. So B to B, that's near 90. Okay, so 90 and 270. Next, stationing of A is 6 plus 421 and B is 6 plus 721. So you have stationing of A and B given. Next, point A is along the tangent passing through PC, and B is through PT. So apparently A and B is not your PC and PT yet. And then look at the last sentence. PCC is along the line AB. So connect your line AB, and that is where your PCC lies. Somewhere there. Right, now, next step, you've created a right triangle. Extend these lines, since it says there that A is in between the tangent passing through PC. Okay, so this is the tangent passing through PC, so that is your A. Tangent passing through PT, that's your B. And then draw your compound curve. Okay, now that you have your drawing, you can now solve. So first part, we're solving for radius of first curve and then radius of second curve. Okay. So we're looking for R, and look at what's given. Here, let's focus on the first side first. Only given lengths for this part. So most likely I need to use that to get to R. So if you analyze this, right, this part right here is actually your T1, which is equal to that T1. And then this part is T2, which is equal to that T2. And remember, the equation for tangent is R tangent I over 2. So if I know tangent, and if I know I can solve for R. So now my goal is figuring out what's tangent and then your radius. So T1 and R1 first. Okay? So let's isolate this this triangle right here, not a right triangle. So it looks like this. So now what we have here is this is your 270, this is your 90, this is your angle bisector. Let's call the length from your station B to PCC as X. And then if you look here, this angle is actually your angle of intersection for your simple curve 1. So that's why this is your I1. And then here, if you look at that angle, this is your second curve. That's your angle of intersection for the second curve. So that's I2. Right. So now using this triangle, we can solve for, or we can create a couple of equations. First of all, I'm given station A and station B. Right? Station A is 6421, station B 6721. If I get the difference between those two stations, I can get this length right here, right? So AB is equal to 6721 minus 6421, that's 300. So the length of this is 300. And not just that, that is your T1 plus T2. So T1 plus T2 equals 300. You have your first equation. Okay? Next, second equation you get from this right triangle. So what you can do here, so this is an angle bisector. Therefore, you have two right triangles. Remember, if you have a perpendicular bisector, angle bisector, it's gonna hit the opposite side at a perpendicular angle. So this is perpendicular. Now you have two right triangles. You're gonna use sine functions, trig functions again. So let's focus here on the left side. So if this is theta, I can say sine theta equals opposite T1 over hypotenuse 270. And sine theta equals T1 over 270. On the same way, sine theta, focusing on this right side, equals opposite T2 over hypotenuse 90. Now I have this second equation there. Okay, so combining these two equations, T1 plus T2 equals 300, and T1 over 270 equals T2 over 90. That's your second angle. That's your second ratio, or second equation. Two equations, two unknowns. I can solve for T1 and T2 using simultaneous equations. Okay? Again, two equations, two unknowns, solve for T1 and T2. So doing that, I'll leave that solution to you. Okay? Because you can use calculator or you can do it manually. So T1 is 225, T2 is 75. Okay. So now I have T1 and T2. My next problem now is solving for I1 and I2. So to solve for I1 and I2, again, you're going to use your triangle. You're looking for an angle. And then look here. This is 270. This is 90. And I already know this T1 plus T2 equals 300. So I know two sides and the length of one side. And I want to know an angle. So one law that you can use for that is your cosine law. So far you've been using sine law. Now let's try if I can use cosine law. Cosine law is just side squared equals c squared equals a squared plus b squared minus 2bc 2ab cosine c. So let's see that. Okay. So c squared equals a squared plus b squared. So in this angle here, I want to know I1. That's your side, opposite side. So 90 squared equals the remaining two sides, 270 and 300. So 270 squared plus 300 squared minus 2ab. So minus 2, the remaining sides as well. So 2 times 2 times 270. And 2 times 270 times 300 times cosine I1. Okay, so using this equation, solving for I1, you get 17.15 degrees. I know T1, I know I1, I can now solve for R1. Okay, so using equation T1 equals R1 tangent I1 over 2, subbing in your values, you get R1 equals 1492.48 meters. So that's number 1. Number 2, solving for R2, radius of the second curve. So you're going to do the same thing. I already know T2, so the only problem now is I2, and to solve for I2, you're just going to use cosine law again. So cosine law, so I want to know I2, opposite side is 270, so first start with 270 squared, equals the remaining angles, remaining sides 90 and 300. So plus 90 squared plus 300 squared minus 290, 300 cosine I over 2. Solving for I over 2, you get 62.18. And lastly, using P equals R tangent I over 2, we can solve for R. So finally, R is just 124.37 meters. Okay, so that's your numbers 1 and 2. Okay. And then lastly, number 3, part 3, two parallel tangents. Let's zoom in a bit. Two parallel tangents 10 meters apart are connected by a reverse curve. The simple curves forming the reverse curve are equal. Chord length from TC to PT equals 120. So let's draw that. Wait lang. Okay, back. So that's what we have. How do we get there? So again, one by one. Two parallel tangents 10 meters apart are connected by a reverse curve. So two parallel tangents. So this is your first tangent, this is your second tangent. And they're connected by a reverse curve. So connected by this curve right here. And they are 10 meters apart. That's why this is 10. Okay, so that's what that looks like. Or if you want, you can draw it this way. Yeah. And then this is 10. Okay, so this is your reverse curve, your parallel tangents. Next, simple curves forming the reverse curve are equal, then the chord length from PC to PT equals 120. So what does that look like? So they're equal. So this curve equals this curve. And chord length from PC to PT, not PRC. Take note of that. So it's from PC to PT. So it's the total length. This to this point is all 120. Okay. So that's the drawing. And those are your data. So next, number 1, compute the length of the combined tangent with common direction. Compute the length of the combined tangent with common direction. So what does that mean? What is that? That is your combined tangent here, right? Or your common tangent. So it's this length. I want to know that. So how? Again, as usual, you're gonna look for triangles. So in our case, okay, again, we're looking for this. I know the perpendicular distance between this line and this line, right? So it's this height. I know that to be 10. So if I isolate that, as you can see, I formed a right triangle. If I isolate that, I get this. So again, this is your 10. And let's call these, is the point given? No, it's not. So I just named this A, B. So line, we're looking for line AB. So next, if you've noticed, this angle right here is actually the angle of intersection of the first curve. And remember, first curve equals your second curve, so that's just I. I1 equals I2 equals I. So to solve for this, okay, I need to solve for I, right? I can use sine function. Sine I equals opposite 10 over hypotenuse, which is what I'm looking for, AB. So now my goal is to solve for I. So how? To solve for I, we can look for another triangle. It's already shown here. It's this. Okay? So isolating that, you get this. And again, this is still 10, right? It's your 10. And it's given that PC to PT. So this is PC, this is PT. Distance between them is 120. And another thing, this angle is actually I over 2. So how? Remember, a simple curve. This is I. This is also I. This is actually I over 2, right? Parts of your simple curve. And that angle is the same as this angle. So that's also I over 2. From tangent to long chord, it's I over 2. And this is actually your long chord. Okay? So that's I over 2. So now I can use trigo functions to solve for I. So let's, using sine, so sine I over 2, this is a right triangle. So sine I over 2 equals opposite 10 over hypotenuse 120. So solving for I, get 9.56 degrees. Now I know I plug in to this, using sine function again for this triangle, sine I equals opposite 10 over hypotenuse AB. And AB is what I'm looking for. Yeah, so just plug in I over here. AB is now equal to 60.21 meters. Okay, done. That's your letter A. That's the common tangent AB. Next, radius of the reverse curve. Again, they're equal, so R1 equals R2 equals R. Remember, so far, to solve for R, our technique is to solve for T. Okay? So T are these lengths right here. Okay? So look, since R1 equals R2, so T1 plus T2 is just equal to twice the tangent length. So that's 2T. So 2T equals length AB, which is what we already solved for, 60.21. Therefore, T is just 30.10. Okay? Now I know T. I'm looking for R. I is already solved for as well. Which is 9.56. So plug that in here. So T equals R tangent I over 2. Therefore, R equals 360 meters. Done. Then lastly, letter C, compute the stationing of the PRC in the stationing of A at the beginning of the tangent with common direction is 3 plus 420. So A is at the beginning of the tangent with common direction. In short, tangent with common direction is called your common tangent. So the beginning of your common tangent is 3 plus 420. So that means, and so I've named it correctly, by the way. So A, that's your A, station 3 plus 420. What am I looking for? Stationing of PRC. This point. Okay? So how do you get that? Remember our stationing is taken along the curve. So this is what I have. I need to go back to PC and then get the length of this to get to PRC. Okay? I can't just add a plus T2. That's incorrect. Because stationing is computed along the curve. So again, A minus this plus arc length. So in equation, station PRC is equal to station A minus tangent length plus length of curve. This arc length is actually the length of curve of your simple curve 1. Alright? Let's write that. So T we've already solved for. Right? It's 30.10. Now I need to know LC, length of curve. Again, length of curve is different from long chord. And length of curve was an equation of IR. So using IR, so I, 9.56 times pi over 180. Remember, always convert degree to radians if it's outside a trigo function. So 9.56 times pi over 180 times R, which is 360, you're going to get 60.07. And then just use this equation. So 3 plus 420 minus 30.10 plus 60.07, final answer 3 plus 449.96. Okay? There. Any questions for quiz number 2? None? Okay, so do you understand quiz number 2? Please answer yes or no. Okay. It's reverse and compound curve. Okay. Next. Close ko na po. Moving on to quiz number 3. Quiz number 3. Okay. So now we're moving into parabolic curves. So symmetrical parabolic curves. Okay, wait lang, break, 5 minutes. Let's have a 5-minute break. So resume 232. Right, we're back. 232. So let's continue. So for numbers 2 and 3, you're gonna solve with me. But for number 1, let's just see. Okay, so number 1, a vertical parabolic curve, a side curve of Lapu-Lapu underpass has a grade of -4%, followed by a grade of +2%, intersecting at station 12 plus 150.60 at elevation 124.8 meters above sea level. The change of grade of the sag curve is restricted to 0.6% every 20 meters. So letter A, compute the length of. So similar to your quiz number 1 and 2, your simple curves and then your reverse and compound. Whenever you're given degree of curve, you can compute for radius. Here, for parabolic curves, whenever you're given change of grade restriction, you can immediately get your length of curve. Okay? So how? So change of grade 0.6% every 20. So to write that, change of grade, that's your R, 0.6% over 20. And remember, we have an equation for R. That's just G1 minus G2 over L, okay, if you look at your notes. So subbing that, percent, so that is 0.006 to decimal over 20 equals absolute value of G1 minus G2. So 0.04 minus 0.02 over L. Okay, solving for this, L is equal to 200 meters. Okay, done. Next, compute the elevation of the lowest point on the curve. So now you have to draw your curve. So let's do it one by one again. First, tangent line, -4 followed by +2. So -4, therefore downward at a steeper slope, since it's 4. Then +2 at a less steep slope at a 2% positive, therefore upward. Okay, then combine that and draw it. You have your parabolic curve, sag. Next, intersecting at 12 plus 150.60, and elevation of that is given as well, 124.80. Next, yeah, okay, that's it. So looking for elevation of lowest point. So if you look here, lowest point is here. Okay? So usually the lowest point is at the end where it's not steeper, flatter, at the flatter end. So here the flatter end is 2%. So most likely Q is over here. So draw that out. I want to know the elevation of that. So to get that, remember we're gonna start with what's given. I'm given the elevation of station PI. Okay, so from this line going upward, if I can get this length, which is just using your grade, plus this length, which is using your y over x squared, your offset equation, I can get the elevation of Q. Okay, so that's just elevation of Q equals elevation of PI plus Z plus y sub 1. Okay, so that's given 124.80 plus, to get Z, again, that's just your grade. So this is a right triangle. This angle is at 2%. Your grade is rise over run. Okay, so it's opposite with your earthworks. So again, here it's rise over run. So 2% equals Z over run, this length. And that length is actually, if you look here, this is L over 2, right? Half the length. And then this is your S, your horizontal distance from PC or PT to lowest point. So therefore that is, to get this length, it's this length, L over 2 minus S2. Okay? Therefore Z is 2%, so yeah, 0.02 multiplied by denominator L over 2 minus S3. Okay? And then plus Y1. So again, Y1 we solve using offset equation. Okay, so first thing, I already know L, so I know L over 2. Next, I want to know S2. So S2 using the equation G2L over G2 minus G1. So sub that in, G2, grade 2, that's 2%, so 0.02. L is 200 over G2 again, 0.02 minus your -4%. So this is 4. So So that's computing for that, you get 66.67. I got S2. Next part is solving for Y1, again using offset method. So Y1 over horizontal distance. Okay, and the horizontal distance from PT is actually your S2. So Y1 over S2 squared, okay, that was on the right side, equals, the equation is H over L over 2 squared. So now my problem is I don't know H, but I can solve for H using the equation L over 8 G1 minus G2. Okay, so L over 8, again, L is 200 over 8 times G1, negative 0.04 minus G2, 0.02. Okay, absolute value. We solve for H, that's 1.5. Therefore, subbing 1.5 here. Then L is 200 over 2 squared. You can now solve for Y1. Okay, and S2 is 66.67. Therefore, Y1 is 0.67. Now I know all of my values. So 124.80 plus 0.02 times 200 over 2 minus 66.67, then plus 0.67. Final answer would be 126.13 meters. Okay, so that's letter B. Next, letter C. Compute the elevation at station 12 plus 125.60. So where is that? If this is 125, this is 150, therefore station 125 is less than that. So it's to the left. So here, I want to know the elevation of that. So the steps for process is the same as letter B. So it's this, from pi plus this height plus y over plus y sub 2. Okay. So again, it's pi plus z2 plus y sub 2. So z2 is easy enough to get. Again, that's just your grade times run. My problem is y2. So y2, you're going to use your offset equation again. So y2 over length, or distance from PC or PT, whichever is closer. In this case, that's PC. So I want to know this length. So how? Well, I'm given stations. So for a parabola or parabolic curve rather, your stationing is along a horizontal line. Okay, it's not along your curve. It's along horizontal line. Therefore, if this is 150.60, if this is 125.60, horizontal distance between them is just the difference between their station. So 150 minus 125, that's 25. Okay? So this 25, remember this is a symmetrical parabolic curve. So this is equal to L over 2, this entire length. And L over 2 is 100, right? L is 200. L over 2 is 100. 100 minus 25, you get 75. So that's why this is 75. Therefore, x squared is equal to 75 squared. So y2 over distance squared, again, that's your 75, equals h over L over 2 squared. Already know h, it's 1.5. L is 200 over 2 squared, so I can easily solve for y2. And y2 is just 0.84. And then finally, to get the elevation, again, it's elevation pi plus grade 4%. So 4% times run. And the run of this right triangle right here is 25. So times 25 plus y2, and y2 is solved for, it's 0.84. So final answer is 126.64. Okay? So that's your number one. Next. And we'll solve the next questions together. Okay? So number two. On a railroad, a negative 0.8% grade meets a positive 0.4% grade at station 2 plus 700, whose elevation is 300 meters. The maximum allowable change in grade per station having a length of 20 is 0.15. So letter A, compute the length of the curve. Okay, so let's draw that first. So we're starting with negative 0.8 to positive 0.4. So negative 0.8, positive 0.4. So this is the steeper end, this is the flatter end. And R is 0.15% per 20. Then station PI is given 2 plus 700 and elevation is 300 meters. So first, length of curve. So to get the length of curve, again, it's similar to the previous question. We're just going to use the equation R equals G1 minus G2 over L. That is 0.0015 at 15% over 20 equals G1 minus G2. So absolute values negative 0.08, 0.008 minus 0.004 over L. Solving for L, we get, let's compute. It's 160. So 160 meters. Okay, next, letter B. Compute the stationing of where a culvert is to be placed. Remember, your culvert should be at the lowest point of your ground. So we actually want to know the lowest point. That is somewhere here. So that's your lowest point. Let's call that again station Q. We want to know the elevation of that. So from PI, so let's call this Y1, and again, this is Z. Then, so this, from PC to lowest point, is your S. So on the left side, so that's your S1. So therefore, elevation Q is just, or again, we're starting with what's given. Elevation PI plus Z plus Y1. So elevation PI, that's just 300 plus Z. Again, to get Z, that's just grade times run. So the grade here is negative 0.8%, so that's just 0.008 times run. So I want to know this length. And that length is actually, remember, from PC to PI, that's your L over 2. This is also L over 2. So this, your run, is L over 2 minus S1 plus Y1. Okay, so our problem now is solving for S1. So S1 is equal to, remember the equation, it's G1L, G1 minus G2. G1, negative 0.008 times L, which is 160, all over negative 0.008 minus G2, 0.00. Okay, computing for that, I think we get 106.67. Okay, store that value. Then you can use it here. Next. So, solving for Y1. So to solve for Y1, you're going to use offset method. And remember, to get offset method, I need to solve for H. So let's solve for H first. So H is L over 8, G1 minus G2. So 160 over 8. G1 is negative 0.008 minus G2, which is 0.004. Again, compute. 160 over 8. This is absolute value, by the way. So 0.008. That is 0.24. Okay, so no need to store since that's the whole value. And then now I can use this. So y over horizontal length squared from PC or PT. So that length is actually, again, S1. Okay, since it's the lowest point. So for example, I'm not looking for the elevation lowest point. It's just somewhere here. Okay, so that's not S1 anymore. Okay, you need to solve for what is that length. In our case, since it's lowest point, that's just S1. Horizontal distance from PC to lowest point. S1 squared equals H over L over 2 squared. I can now solve for y1. Okay, so y1 is just equal to 0.24 over L over 2 squared. So that's just 160 over 2 squared times S1, which is 106.67. Then you get, oh, oh, 0.43. Let's see again. Are we looking for elevation? Stationing. We're looking for stationing, letter B. Stationing, I've already solved for that. Let me just move all of that here. My bad. We're looking for stationing, not elevation. Stationing of culvert. I want to know station Q. Okay. So station Q is just, again, we're going to work with what's given. So station PI minus, so from PI, minus L over 2, I'm going to get to PC. Then plus S1, I'm going to get to station Q. Minus L over 2 plus S1. I already know all of those values. So 2 plus 700 minus 160 over 2 plus S1. S1 is 106.67. Okay. So 2,700 minus 80 plus S1. Answer is 2 plus 726.67. Okay. Great. And then letter C, let me just move that computation over here. Yeah. Okay. Okay, letter C. At what elevation must the invert of the culvert be set if the pipe has a diameter of 0.9 and the backfill is 3 meters depth? Neglect thickness of pipe. Okay, so neglect thickness of pipe. So what does that look like? So, so this is your station Q. Want to know what elevation is your pipe? So that's your pipe. Pipe has a diameter of 0.9. Diameter 0.9 What else? Backfill is 0.3. So 0.3. So I want to know the elevation of this. So it's this point. Okay. So to get that, it's what we've been doing earlier. So elevation. So first, I need to know elevation Q. After knowing elevation Q, I'll just subtract 0.3 and 0.9 to get the elevation of this. Okay. All right. So I don't have to delete this. Very nice. Okay. So I have already established how to get elevation of Q, right? All I need now is to solve. Okay, so elevation of Q, 300 plus 0.008 times L over 2, again, that's 80, 160 over 2, minus S1, which was 106.67, plus Y1. Y1 is 0.43. The answer is 300.21. So store this value, and then let's say elevation of culvert is just elevation Q minus 0.3 minus 0.9. Okay? So final answer, you get 299.01 meters. Okay? You understand number 1 and 2? Please answer yes or no. If you have any questions, just ask. Okay, how about the others? Please answer. If you understand, yes or no.
Ma'am? Ma'am?
Yes, yes.
Di ba po bang quiz 3 po ito?
Please get okay. Oh, quiz 3.
Okay, thank you po. Top 4 po eh.
Okay.
Thank you.
Thank you. Okay, we're done. Next, number 3. All right, number 3. Let's read. A symmetrical parabolic summit curve connects two grades of +6 and -4%. It is to pass through a point P, the stationing of which is 35 plus 280, and the elevation is 129.30 meters. The elevation of the grade intersection is 200 meters with stationing 35 plus 200. Letter A, determine the length of the curve. Okay, let's compute. Let's draw first. So we have +6, then -4. So +6, -4. Next, drawing that. What's your PC? PP? Next, we are passing through point P. So 35 plus 280. Mhm. And if you've noticed, let's start with PI first. Elevation of grade intersection 200 stationing 35 plus 300. Okay. So point P is 35 plus 280. So that's less than your point of intersection. So it's to the left. It's somewhere here. So your point P 35 plus 280. Okay. And then elevation 193.13. We're looking for length of curve. Okay. Let's start. We're looking for L. So most likely we'll use, okay, yung mga may finals sa EE may go. Panoorin nyo na lang. Okay. Okay, so okay, so usually again when we get L, to solve for L, we're using offset. Okay. So Y1. Okay, and then okay. So this is 280, this is 300, therefore. Again, this is just the stationings for parabolic curve is taken along a horizontal line. So this 300 minus 280. So this is 300 minus 280, that's 20. Okay, and then this is just L over 2 minus 20, right? So using offset method, so that's Y1 over horizontal length from PC squared. So it's this. So L over 2 minus 20 squared equals H all over L over 2 squared. Okay? So now I need to know Y1. I also need to know H. Okay? So let's start solving for Y1 first. We got Y1. It's just, yeah. So I'm given elevation of this, Y1, and elevation of this point. Okay. These 2 points are given elevation. If I get the difference between them, I get this length, right? And subtracting this height, I can get Y1. Okay. So again, difference between elevation of your PI and P, you get this height, minus this portion, you get Y1. So that's hard. So 200 minus 193.13 minus this. And remember, that's just using your grade. So 0.06, that's the grade times run. this run, and that run is actually this, or 20. So solving for that, 200 minus 193.13 minus 0.06 times 20. You get y equals 5.67. Yeah. 198. Okay. Dapat. Okay. Oh, it's 193. Mm-hmm. Okay. 193.13. So 5.67. Alright. Next, already known y1. Next goal is to look for h. And h has the equation L over 8 times G1 minus G2. Okay. So L over 8, G1 is 0.06 minus negative G2, so that's plus 0.04. Okay. Right, so now I have H in terms of L. I can rewrite all of this. So now we get 5.67 over L over 2 minus 20 squared equals L over 8, 0 plus 0.06 plus 0.06 plus 0.04 is just 0.1. All over. Okay. So now I can solve for L. Okay. Can anyone try? Solve yung L. No, 9.88 is not possible. No. Remember, this is already 20. So 9 is not possible. There's another answer to this. No? So hint, it's greater than 100. No? It's greater than 100. This is squared. Okay, correct. Yeah. John. Yes, it's 530.58. You're correct. Everyone who answered 530.58. Okay. Okay. So that is the answer to letter A. Next, determine the stationing of PC. So here, stationing of PC, again, that's along a straight line. So you're just gonna get the stationing of PI. So stationing PC is just stationing of PI minus L over 2. Okay, so stationing of PI is 35 plus 280 minus L over 2, and L is 530.58. So the answer to that is 35 to 80 minus. So 35 plus 0.14. Okay, 530. So 35 plus 0.14.71. Okay, next, stationing of PT. That's again easy enough. So same thing. Station PT is now station PI plus L over 2. Or station PC plus L. So 35 plus 280 plus L over 2. So the answer to that is 35 plus 545.29. And then lastly, letter D, elevation of PP. So elevation of PP. So to get that, it's just starting from pi again, then plus z, or minus z. Let's call that z. So L of pt is just elevation pi minus this height, which again is z. Okay? So that is 200 minus. So to get height, again, that's just right, grade times run. So 0.04 times your run. So this run is actually your L over 2. Okay? So answer is 200 minus 0.04 times 530 over 2, 189.39 meters. Okay, so that's it. We're done with quiz number 3. Any questions? None? Do you understand solutions to quiz number 3? Please answer yes. Okay, great. So quiz number 4. Quiz number 4 is exactly the same as the examples given for your unsymmetrical parabolic curve, just different values. So I won't explain that anymore. Instead, I'll just post the solution. Okay. Sige. So instead, again, I'm just gonna post the solution and answers to your quiz number 4 so that you can recheck it with your own. So by the way, I have not checked quiz number 3 onwards. So only 1 and 2 I've manually checked. I'll manually check 3, 4, and 5 within the week. Okay, so don't, if you're wondering why ganun pa rin score nyo, I'm gonna check for the discrepancies with your decimals and units. Okay, so don't worry about that. And then tomorrow, group 5 and 6 will report. Okay. As a reminder, group 5 and 6, please send your written report to me by the end of the day so that we can start with your reporting immediately on tomorrow. Then there's no meeting on Friday. Then on Saturday, uh, I'm thinking if we have a verification. So verification just means letting you know what score you need in your finals to pass this class, and if you have any unsubmitted requirements, okay, on Saturday. So I'm thinking if you'll have verification, I'll just give you a free day to review for your finals the next week. So let's talk about that tomorrow. Right? Then finals next week. I've already given you the schedule for that. Right? Do you have any concerns before I dismiss you? So, by the way, for group 4, there's one of you who hasn't just reported yet, so you'll be the first one to report tomorrow. Yes, Raymond. Pag-usapan natin mamaya. I'll message you sa course messages. Ano? Naka-auto correct ka ata eh. So, Thursday or Tuesday exam. Let's see. Anong sinulat ko? Is it here? Yes, coding. Hi, Raymond. You're the first one to report tomorrow, and let's talk about your quiz later. 18. Wala yun. Thursday. Thursday finals, 6 to 9. Tomorrow, group 5 and 6. Then Raymond, group 4. Any other questions? Lana? Okay. Lana, see you tomorrow. You may go. Goodbye, class.
Bye, ma'am. Thank you po.
Thank you po, ma'am.